covers more than 70% of the Earth's surface. The ocean is the planet's lifeblood, but it's being transformed by climate change. Every day, Darwin travels from the Pacific islands of Palau to fish on the northern reef.
The reef is very important because fishing, that's our way of life, our culture. Before we used to fish on the reef, inside the reef. But now the corals die and there's not much fish on the reef. That's why we're heading into the deeper water, the blue water. If I cannot find the fish, then the family is not going to survive much in Palau.
For years, Darwin's made his living around the coral reefs that form the heart of an underwater community. Colonies of tiny animals. Corals host 1 in 4 of all marine species. But they're dying. Over half are gone already. The rest facing extinction on a scale that could lead to devastating changes for the ocean, the planet, and everyone on it. In Hawaii, a group of scientists dedicate their lives to saving corals.
The cost of doing nothing is enormous because we could lose one of the most significant ecosystems on our planet.
Oceans are dying, our reefs are dying. Sometimes you want to just scream and shake people and be like, wake up and look and pay attention.
They are pioneers using cutting-edge technology and methods to help corals make a comeback.
In the lab right now, we're doing some tests with the corals that... Uh-oh. In the lab right now, we're not allowed in. 5 minutes. Okay, 5 minutes.
Dr. Ruth Gates has been working to preserve corals for the last 26 years.
Oh, look at that. That's cool. That setup over there.
So we're measuring photosynthesis and respiration rates of the corals.
In my first dive on the reef, I dropped my regulator out of my mouth. I was so awestruck by this underwater garden that was before me. Stunning, stunning architecture, so busy, so beautiful. Today, what we're looking at is a semblance of that past self. It looks like a battlefield. There's nobody home. It is devastating to watch the death of the system you love before your very eyes.
It's not just the beauty of corals that's being lost. Reefs provide crucial protection from storms and food or resources for 500 million people. Even the air we breathe, up to half the planet's oxygen comes from the ocean and the corals within.
Should we be doing everything in our power to protect coral reefs at this point? The answer is yes, because in protecting them, we're essentially protecting ourselves.
Once a rich man's playground and the set of a famous television series, Coconut Island is now on the front line of the battle to save corals. It's home to a group of young researchers like Ginny, who work under pioneering scientist Dr. Mary Hagedorn in the Hawaii Institute of Marine Biology.
When I was a kid, I wanted to save the planet. And I think this is part of the way that that's going to happen.
Ginny is part of a team whose approach owes less to the secrets of the ocean and more to human fertility treatments. At the reef, the team collects sperm and eggs from the corals, then rush their samples back to the Hagedorn lab.
We have this rack that we freeze sperm with. We developed it in our lab, even though this seems like a sort of makeshift contraption. It's actually very well thought out. And really, this is everything we need to freeze our coral sperm. We use technology that was developed in human fertility clinics. They're frozen a lot like human eggs, which is interesting, I think.
The plan is to create the largest repository of corals in the world, a type of Noah's Ark for corals. But that's easier said than done.
We've worked to try to freeze these for 7 years. It took us 7 years to figure out how to freeze them. The whole process will take about 4 minutes. I like it when you put your hair like that, and it all just kind of like...
I think I could do short hair. I just don't think I could ever dye my hair.
Oh.
Yeah.
Are we there? Yep, cool. So once the samples get down to minus 80, then they all get plunked into liquid nitrogen. These samples will stay in liquid nitrogen for at least 10 minutes, and then they'll get transferred into our storage containers. And theoretically, they can remain there and be stable for hundreds or even thousands of years. When I started, we were making an insurance policy for the future. And in the 12 years, it's gone from creating this insurance policy to creating a bank of material that needs to be used right now.
It's a race to harvest the basic building blocks of life before these tiny animals die.
Are you okay with the rain?
But the reproductive habits of corals don't make it easy.
Reproduction for most corals only happens once a year. Just a couple nights and only a few hours per night. So it's a really limited window of opportunity to get that material frozen and banked down.
Cryopreservation of coral was pioneered by the head of Ginny's team, and there are still only 5 people in the world dedicated to this painstaking task.
We've banked down quite a few coral, but we're still under 20 coral. Of the 800 coral in the world, we still have under 20 in our banks. Our coral reefs really provide so much for us, and so what's going on there is really more about what's going on for all of us. If it ceases to be or ceases to function the way that it's supposed to, it's going to make it so that we can't function the way we're supposed to either. It really comes down to not just a problem with the ocean, but a problem with our planet that will eventually impact us.
Climate change has caused our oceans to rapidly become warmer and more acidic. In Palau, a chain of small islands in the Pacific, marine biologist Yimnang Golbu is studying the impact on coral reefs.
We're doing surveys of the fish, corals. The damage was some places almost 100%, and some places not as much. Oh, all right. Okay.
Yimnang is monitoring harm done to the corals here that has now been found on reefs the world over. It's the tiny algae living within each coral who really feel the heat of climate change. These plant-like organisms give reefs their vibrant colours, but traumatized by ocean warming, they're forced out, killing the coral they leave behind. But in a nearby bay, Yimnang has made an extraordinary discovery. Beneath the surface here, the corals are flourishing.
The mystery that this place holds gives us hope that we can somehow save corals.
So you have a lot of these foliose corals. There's the massive corals, the branching. So what we'll do is we'll just get in there and we just swim. Get ready and just jump in.
Yimnang found that the corals in this particular bay seemed immune to the effects of climate change.
We started this coral reef monitoring program where we go around to different places in Palau and we monitor the reef and look at the reef conditions. We found out the Nico Bay area, they recover really fast. So that told us that corals here are strong and they're not susceptible to warmer waters. We wanted to try to understand how were they able to survive in this kind of environment.
Yimnang's research revealed that the waters here have been naturally warm for millennia. It's not the heat itself that's killing corals. It's the trauma of the rapid change in temperature.
Over hundreds to thousands of years, corals here in Nico Bay have naturally evolved to gain this resilience to warmer temperature and more acidic conditions. It's important for us to understand how did that happen. And if there's a specific gene that allow these corals to survive, can we use that information and maybe breed for that gene in different corals, or can we transfer that to other corals in other places?
It's an urgent task. Over 90% of global warming in the past 50 years has occurred in the ocean. And with water temperatures rising at an unprecedented rate, evolution is fighting a losing battle. So scientists have decided to give it a hand.
The solution that we're proposing is controversial because we're talking about human intervention, engineering.
Dr. Ruth Gates has a plan to speed up evolution by creating supercorals capable of surviving climate change.
Please, could I get the silver cup right there, Craig, so I can actually have coffee before we get in the water?
Today, Ruth is looking for the healthiest corals on the reef to work with.
The corals here are amazing. This is our natural laboratory. Coconut Island is over there. We're looking to identify the strongest corals on the reef and then use those to develop corals that are even stronger, that can face climate change. Let's find that goddamn mask and put it on.
How's that?
Feels good.
Yeah?
This reef is really a good example of the amazing three-dimensionality. They're not just beautiful to look at, they house a huge number of other organisms. But they also act as natural seawalls, natural breakwaters, really cutting the energy of large storms that come in that would erode the land directly behind them.
Ruth takes a sample of the strongest looking coral on the reef.
You see those turtles? Yeah. It just came out on demand. We had 2 huge turtles that just came out. That was really nice. It was fun.
The specimens are taken back to dry land, where Ruth has created a type of coral gym. Here, corals in confinement are exposed to conditions that simulate the effects of ocean warming in the future.
These experiments are really stress tests. Our goal is to give corals experiences that stress them out a bit, but that don't kill them. And we believe that that experience gets fixed as a memory, and the next time they see that similar stress, they don't see it as stress. They just see it as something they're used to seeing.
After the corals have gone through an excruciating training regime, Ruth then selectively breeds the best of them, like pedigree dogs have been bred for centuries.
All of these on the plugs, can you see the round plugs? Those are all offspring from selective breeding. We did in vitro fertilization and created the next generation of corals that have been selectively bred.
The supercorals are then taken to the reef, where Ruth hopes they'll now have the ability to deal with the stress of climate change.
This is the cutting edge of the science. It's exciting work. You know, it gives me hope that we can do something to generate biological capacity to restore damaged reefs.
But right now, the pioneering work of Ruth and others is just a drop in the ocean. Until their methods can be applied on a global scale, there'll be huge challenges ahead. For the oceans bearing the brunt of climate change, for the corals still facing extinction, and for the men and women across the planet whose lives will be transformed.
Just not like it used to be. It's only 6 fish in 2 hours. That's a lot of time for such a few fish. We won't be able to feed everybody and sell fish, and before we know it, it's all gone.
Will this strategy alone be sufficient for all places? Absolutely not. We have to think about protecting places that are doing better than expected, the reefs in the world that are these hope spots. But perhaps most importantly, I think that we need to come together and think more creatively about what our science can do, or decisions will have to be made, and we will have to let go and make difficult decisions about some species and even potentially some places. We have got to start acting now if we have a hope of preserving and sustaining reefs.